All right, so today we're doing section 10.3, which is ellipses. Now, last time we did a circle, so we know that a circle is defined by a center and a radius. Now, an ellipse is going to be more of an oval, and it can either be oriented horizontally or oriented vertically. So again, either oriented horizontally or oriented vertically. So how exactly do you make an ellipse? So it does have a center, but it has these two special points that we'll talk about in a minute. So take this, we have 2 points, and all right, so these special points are called the foci, or the focus. I'll go through that in a minute. So again, when you have an ellipse, you have a center, and then you have the two focus points, okay? And then that's how you make your ellipse. Another thing to note is that this distance is actually the same for the entire ellipse. So imagine if I had this line here and this line here, right? And as I move it around, even if I had this right here, this distance is actually going to be the same as this distance right here. And that actually makes sense. Why? Because it's the same string. So no matter, the string length is the same. So no matter where I move it, that distance is the same. And so that's actually the definition of your ellipse: center, focus points, and so forth. Don't write this down. Just kind of make sense of it, and then we'll take notes. So for this, you know that in an ellipse, you have your center. You have your two focus points, which that's how you make your ellipse. And the plural form of focus is called foci. You have your vertex. Your vertex lie on your major axis. So this right here is your major axis. And of course you have your minor axis. Can you guess which one is your minor axis? Yes, that's correct. This would be your minor axis. So we have your major axis, your minor axis. You have your each vertex, which always falls on your major axis. The plural form of vertex is vertices. And again, your co-vertices lie on your minor axis. Now, this is if it's oriented horizontally. If it was oriented vertically, the same is still going to be true. This is still your major axis. How do you know? Because it's always along the longer one. So this is still your major axis. These become your vertices, and these are still your co-vertices. It doesn't matter which way it's oriented. Now, the only other thing to know about these is they call these certain distances. So you have an A, B, and a C value, and this is very important. And again, you're just listening for right now. You'll actually take notes on this in a minute. The distance between your center and your vertex, regardless if it is oriented horizontally or vertically, is your A value. So this is A and this segment is A. The distance between your center and your co-vertex, this distance, again, it doesn't matter how it's oriented, is going to be called your B value. So we have A, B, and there's one more missing. It's C. What do you think the C distance is going to be? And that's really important. The C distance is going to be from your center to your focus point. And the reason these points are important, or these distances, is because there's actually a formula that can help you solve them. If you know two of them, you can always find the other one. So again, regardless of how it's oriented, this from center to vertex is your A value. From your center to your co-vertex is your B value. From your center to your focus point is your C value. Okay? And you can actually look at these and kind of say, oh, which one of these values is going to be the greatest? Well, it has to be your A value. You're going to write this down. So this will be the beginning of your notes, section 10.3. It's in your textbook on page 634, and they actually will give you more formulas than I will. I will teach it for you guys to just think about it more, but this actually has more formulas. So go ahead, copy this down, and we'll leave some space right here for our picture. So go ahead and copy these diagrams down. And again, these are the same diagrams that we had talked about on this page. It says, if it's oriented horizontally, they're your vertices, co-vertices, A, B, C value. If it's oriented vertically, here are your vertices, co-vertices, A, B, and C value. There are two forms. If you look at this, you can see that for it oriented horizontally, the A value is always going to be that bigger number. So if the bigger number is under the X, it's oriented horizontally. If the bigger number is under the Y, it's going to be oriented vertically. Now, they could have switched these and written them differently. It doesn't really matter. All you have to do is look at an equation and see where the bigger number is, and it'll tell you which way it's oriented. So again, you can look at this. The number under the X tells you how much you move horizontally. The number under the Y tells you how much you move vertically from the center. Another really important thing to note is that always, always, always will equal 1. So again, both of these always equal 1. And the last piece of information is we know our A, we know our B. How do we find C? You have to use a formula. So their relationship says A squared minus B squared is equal to your C squared. What do I kind of remember from the formulas? They are different. I just tend to memorize this one and this one. Now, if you look at your textbook has all of these formulas that you can use to find your center, your foci, all of this. And this is on page 634. I won't actually teach it this way. I just have you think about it. But if you find your H, K, A, B, C value, you can definitely use the formulas. All right, let's graph some. All right, so here's our first graph. And the first thing you have to do, like when we come to a test, there's going to be different graphs that you're going to do. So you're going to have to look at this and say, wait, is this a circle? Is this an ellipse? Is this a hyperbola? Other things. So what you do is you say, well, you know it's not a circle because it has a denominator. It has a plus sign and it equals 1. So you know that your graph is going to be an ellipse. First thing you're going to do, and you can answer these first. I always graph it and then find my answers. So the center, be careful. The center is your X and your Y value. So it is at -4, +3. So -4, +3. And you could just graph this, or I attached some graph paper on your Canvas sheet that you can print out as well, or just kind of grid it out. -4, +3. So there's your center. Now, the number under the X tells you how much it's going to move horizontally from your center. Square root of 9 is 3. So that means that your A value is 3, or you're going to move 3 units left and right. The number under the Y is going to tell you how much you move vertically from the center. So square root of 25 is 5. Actually, this is not your A value. Your A value is always going to be your biggest number. So this becomes B and this is A. So 5 units vertically and 5 units down. Then you're just going to graph it. So I went ahead and graphed it, labeled all my points, and it's easy to see what my center was, what my vertices were, and they didn't ask you for the co-vertices, but sometimes they do ask you, or the length of the major axis. The length of the major axis would have been 10. The length of the minor axis would have been 9. All right, the only thing that I'm missing are my focus points. So in order to find my focus points, I have to go back to the formula. Find my A, B, and C value. Well, I know my A, B, and C value. Let me write my formula. So to find the focus points, we're going to use the formula C squared equals A squared minus B squared. Write this down. A in an ellipse is always going to be the larger number. So A is 5 and your B value is 3. And then we're going to have to calculate our C value. So plugging this in, 5 squared minus 3 squared, 25 minus 9, square root both sides. So your C value is 4. That means that your C value is 4. Do you guys remember where the C value goes? Well, the C value is the distance from your center to your focus point, okay? So that distance is C. So I'm gonna plot that point, it's 4. Here's my center, so if I go 4 units up, that's my focus point. And if I go 4 units down, that's my focus point. Write down the coordinates. So my focus points, wrote it down, are at -4, 7, and -4, -1. And again, they always lie on your major axis. These numbers will not always work out nicely. Like sometimes there'll be a square root of 3, and then you just keep your answers in terms of square roots. All right, I'm going to redo this problem again, now using the formula. You don't have to copy it down, just watch it or fast forward to the next problem. All right, so once again, for me to do this problem, I have to graph it, and then it's really easy for me to answer the questions. I don't really memorize anything. Now, if you go back to page 634, they have a formula page. And this is what it says. It says, well, actually, just find your A, B, C, H, K values, and then use the formulas to answer all the problems. So here's the formula page on page 634. Make sure it's the right orientation, so oriented vertically. Here's a formula. Find your H, -4, K, +3, A is 5, B is 3, and then you still have to do the formula to get your C value, 4. Done. Once you have that, then you can go back and say, okay, your center, based on the formula, is HK, -4, 3. Got it. Your foci is going to be H, K plus or minus C. So H, -4, K, 3 plus or minus your C value, and then whatever that is. So -4, 3 plus 4 is 7, -4, 3 minus 4, -1. Vertices, you're going to do the exact same thing. So your vertices are going to be H, K plus or minus A. So H, -4, K value 3 plus or minus 5, and then work that out. So you can see you have all of these answers, no graph needed. You can just go straight to formula. This for me is very difficult. I have to use the graph. But if you like the formulas and you have access to them, which you will, then you can just do the formulas. So it's kind of up to you whether you like formulas or just thinking about it. Okay, again, I always just graph it.